Has Christmas arrived early this year? Because something definitely interesting just arrived at my doorstep. A blank brown box with a text for an overclocker labeled on top of it. What could be inside? I think we should take a look. And voila! Here's the long-awaited and highly anticipated EVGA SR-3 DARK, or the Super Record 3 DARK. Many people have been asking that will it even go retail, because it has been pushed forward many times already without any exact information about the final launch date. But this is the final retail version of the motherboard, and it will be hitting the market around New Year. So even when it's not inside retail packaging, this is the retail version of the SR-3 DARK. Of course, the retail one, when you buy it inside the store, doesn't come with a lapped 28 Core Xeon 3175X already installed in the socket. But without further ado, I think we should take a close look at the motherboard and see what kind of features are present on the motherboard. Alright, so that's how the board looks like in a more closer view. So the first things you can obviously note straight from the get-go with the SR-3 DARK is the rotated socket, just like on the Z390 DARK. So that should help a little bit with the actual airflow around the socket area to keep the components cool. I'm not fully sure if it actually helps with any of the signal quality at the motherboard's PCB level, but it certainly looks different. It's quite unique to EVGA right now. There are no other vendors that are doing something like this with the motherboards. Then the motherboard is obviously much wider than your standard ADX motherboard. So here are the standard ADX mounting holes. So the SR-3 DARK is probably like 10 centimeters wider than your standard ADX motherboard, or a bit above 10 centimeters. But it's not any longer, like in terms of height, like in this way. So it's the same. It is as long as your standard ADX motherboard. So it should help a little bit with the overall compatibility with cases. But obviously you still have to obtain a case that can fit a very wide motherboard like this inside it. Then lastly is probably the included water block that cools the VRM part of the CPU as well as the PCH on the motherboard. So I think the SR-3 DARK is the only motherboard out there right now on the market for this platform that has included water block for the VRM out of the box. Pretty much all the other ones out there are just big air cooling heatsink. I'm not fully sure how the VRM is wired, like which parts of the VRM are underneath this heatsink over here, but most of the VCore VRM is definitely underneath the water block over here. So I think the water flow is so that here's the inlet, it goes through the VRM part first, then over the PCH, and then it just exits from here. So I might try later on to use water on the VRM plus on the chipset, but even just like that, I think you should be totally fine on running the motherboard for testing purposes, even daily, with mild overclocks when you are just running the water cooling heatsink assembly as a passive heatsink like that. So I'm pretty sure you wouldn't have to worry about bad temperatures, even if you don't use water on inside the heatsink. But yeah, so I don't know the exact VRM components of this motherboard, so I need to disassemble the cooler so that we can take a closer look at the actual power delivery components themselves. But I would expect they are using the same interstitial components as on the X299 DARK and Z390 DARK. So maybe something like 16 phases for the actual CPU VRM. So we have to check it soon, but it should be good enough anyways. Also, you can probably notice straight away is the how large the actual CPU is. So with the LGA3647, we don't have normal mounting holes anymore around the socket area. So we have to mount the coolers differently. Right now I don't have like real proper cooling solution yet for the CPU. there aren't that many out there on the market. I would expect that most people who are buying this platform, they will be running custom water cooling on the CPU. I couldn't find any 3647 AIOs here in Finland. I could only find the big Noctua coolers made for this socket, and then just custom water blocks. So right now I have the Fantex 3647 narrow ILM water block coming in soon. So I will use that later with so that I can make proper tests, even just the water. But I think I'm not fully sure about this, but I think you could actually mount your standard water block. So the standard water block you use for mainstream CPUs, X299 CPUs, and just old CPUs in general. If you use the LN2 rods on the bracket over here, so if you use the rods in these holes over here, they are actually the same dimensions as Intel LGA 115X, 2066, and so on. So if nothing at this, if nothing of this mounting bracket over here prevents the actual contact with the CPU, with the CPU water block, you should be able to run at least some basic tests with just normal water block. Obviously, that is not the optimal situation, because the most of the normal water blocks, they cannot cover the entire IHS because it's so big. But the actual die of the CPU is actually fairly small at the middle of the CPU over here. So if you have watched, for example, Dave Bauer's deleting video of the 28 Core Xeon, you can easily see that the actual CPU die is fairly small, the center of the CPU on top of the second PCB. So it should be good enough, even for some mild overclocking tests, if the entire die is covered. One issue could be the inadequate mounting pressure on the CPU pins, because there's no like clamping mechanism that is common with Intel CPUs. So it's not so easy to get even pressure across all of the pins to run the CPU and platform without any issues. So you could lose some memory channels. So I have to test that, but I will give it a try with the normal water block using the rods over here. Then one thing of note is obviously that the SR-3 DARK only has one memory slot per channel. So pretty much all of the other motherboards out there from other manufacturers, they have 2 memory slots per channel. So this only has 6 memory slots in total, as there are 6 memory channels. So that should definitely help on reaching the best possible memory configurations on this motherboard. I'm not fully sure how this looks like in the eyes of a very high-end like workstation builder, because this obviously limits the maximum amount of memory you can install into this system. But right now we even have those very high capacity DIMMs out there on the market already. So even with those, I mean, if you use those, you can get quite a lot of memory with just 6 memory slots in total. So that is up to you to decide what is good or not. But for performance-wise, it definitely helps when there's just 1 slot per channel. So the chipset of the motherboard is actually the Intel C622 chipset. So most of the other boards, like for example the Asus Dominus Extreme, the Gigabyte Aorus Extreme, they have the C621 PCH or the chipset. I'm not sure what is the difference between those two, but this has the slightly newer version of the chipset installed. Then I think we can take a closer look at the rest of the motherboard, go through the PCB, what is installed. So the board has 6 PCI Express X16 slots over here. So you could run 3-way and 4-way SLI with graphics cards that can actually support it in these slots over here. Kimpin already ran 4-way SLI with 2080 Ti Kimpin cards, all on LN2 as well as with the CPU on LN2. And he managed to break the TimeSpy Extreme record easily with a large margin over the guy at the second spot. So that already shows that how good this motherboard combined with a good CPU and graphics cards can actually do. When it comes to the CPU part, in terms of overclocking, I'm sure the motherboard can handle the load of the 28 core just fine. Kimpin, for the time spy extreme record on LM2, he managed to run the CPU up to 5.8 GHz throughout the whole test. That is extremely high speed for a 28 core Xeon like that. And even just the water, he could run the same test at 5 GHz to 5.1 GHz stable. I mean, that is an extremely nice number, to say the least. That is higher than many of the normal Skylake X CPUs can do. So that is really, really impressive. Then you can obviously note the same cutouts for your power connectors, just like on X299 DARK and Z390 DARK. So there's a cutout for the supplementary PCI Express 6-pin power connector over here for the PCI Express slots, and then cutout for the 24-pin and as well as for the 8-pin power connectors. They are actually easier to note from the back side of the motherboard. So we can take a very close look over there. The motherboard is actually really, really heavy due to the all the heat sinks that are on the motherboard. So here you can quickly note the cutout over here for the 24-pin and the CPU power connectors, as well as for the supplementary 6-pin over here. I'm not fully sure that will they actually have a copper backplate on the final retail one that you can find inside the packaging, but the board changed a bit from the version that was showed at Computex. So right now, especially on this version, there are no M.2 stuff over here on the backside of the motherboard. So I'm not sure if there are any M.2 things on like underneath the PCH heatsink assembly, because if you just look at the motherboard from this side, there are only 2 full-length M.2 ports. One is between the first and second PCI Express slot over here, and one next to the PCI Express slots over here, just over the 6-pin power connector over here. The audio part is separated from the rest of the PCB, as you would expect. It is quite standard nowadays with many boards out there. Then, when going forward with the motherboard, at the bottom side of the PCB, there's your post-process speaker. Many don't like this at all, but it's quite common with EVGA motherboards still. So it will make a noise when you have passed your post-process. Then here's some internal USB port for your case, I think. Some 4-pin fan connectors over here. These are all of these are actually rotated 90 degrees, so it can make your cable management a little bit tighter. Here's your VRAC key for your VRAC ports, which are over here. One internal USB 3 port for your case. Rest of the case front panel connectors are over here. Then there's your Cmos battery. And actually, a funny thing I noted right now already, the motherboard. So if you look over here, there are 7 PCI Express disabled switches over here, but there are only 6 PCI Express slots on the motherboard. So I'm not fully sure that what the 7th one is doing. But anyways, it's still good that they are present on the motherboard. If you have many cards installed in a single water cooling loop, and one of them starts to give issues, you can easily troubleshoot and fault find that what is the faulty graphics cards. I mean, which one is the faulty graphics card that is causing you issues, without having to break the loop and test them individually. So that really, really helps a lot. Here you can find a Cmos clear button. There are actually 2 of them present on the motherboard. One is over here, and one is at the rear I/O part of the motherboard. It's good that they are present on the motherboard, and this is quite easy area to reach when you are testing the motherboard outside a case. And the black one is a safe boot button. It's very nice. There are 3 BIOS chips present on this motherboard. 2 of them are soldered on the board over here, and the first one is a removable one in this plastic socket over here. So it's very hard to completely brick the motherboard with corrupted BIOSes and failed BIOS flashes. So even if you happen to fail with most of them, you can still get a new BIOS from EVGA, swap it inside the socket, and then you can recover the rest of the 3 with that one which you just installed. You can choose between the 3 buses with the switch over here. So it's very, very nice. Then let's take a look at the storage part of the motherboard. So here you can note that there are actually only 6 SATA 3 ports or SATA 6 gigabits per second ports. That is actually quite low value for a workstation oriented board like this. I would expect that they would put more on a motherboard like this, like 10. But it appears so that nowadays the storage solutions are moving more towards PCI Express just because of the high bandwidth. So they are not increasing the amount of SATA options, they are just increasing the amount of like M.2 ports and similar. But anyways, there are 6 over here, and then is it 3 or 6 VROC ports over here. I'm not sure, will you connect 1 or 2 drives into one of these, but anyways, there are at least 3 of them over here. Then here's your power connectors, so the big 24 pin, and you can also note that there are 4 EPS 12 volt CPU power connectors present on this motherboard. There is absolutely huge amount of power availability on the input side. But the funny thing is obviously that there's still not a single power supply out there on the market that can run 4 EPS power connectors for the CPU or power cables for the CPU. So if you really wanted to populate all of the 4, you would have to combine two power supplies into one. So that just connect the 2 24 pins together and then connect that to the 24 pin on the motherboard, and then just run two 8-pin CPU power cables from each power supply. But it is totally fine to just run only 2 power connectors over here. So on these 2 over here, Kimpin ran just 2 over here for all of his tests. So it is totally fine to just run 2. We will see if we have more like larger power supplies coming out soon to the market that have more than 2 8-pin power connectors for the CPU. Because this whole socket should have some lifespan left. Intel should be releasing more CPUs to this platform, so I would expect that the power supply manufacturers will be releasing more like high-end oriented power supplies to the market soon. Then when looking at this part of the motherboard, we have the power and reset buttons over here, a slow mode switch over here, and then we have the debug LEDs over here. So these give you normal postcodes, but you can also use them as a monitoring device, just like on X299 Dark and Z390 Dark. So you can see the, for example, CPU die temperature. To follow if you have cracked your thermal paste on LM2, you can monitor the CPU VRM temperature, very handy for normal use, and then most of the key voltages from these 2 debug LEDs over here. So that is really unique to EVGA, and I really like that feature on the motherboard. Then when looking at the top side of the motherboard, we can see that there are 2 Pro-bit connectors present on the motherboard so that you can check most of the voltages with a digital multimeter. I would expect again that every second pin on these connectors is a ground pin. So but you can find the information all online, obviously. Some 6-pin connector over here. It almost looks like an EVBot connector from the past years, but I'm pretty sure that is not an EVBot connector because EVBot is a 5-pin. And why would you use that old device anymore with a new motherboard like this? But we can find the information about this later. Then there's a funny like USB port present on the PCB over here, and there's a text BIOS update written next to it. So maybe this is some kind of a BIOS flashback utility over here, so you can update the BIOS without CPU installed, with just passive power coming from the power supply. So if that is what I think it is, it's very nice that it exists. Obviously, it would be easier if this port was at the rear I/O part of the motherboard and not here next to the memory slots and everything. But yeah, here we have 3 more 4-pin fan connectors, so for the CPU and etc. So if you had, let's say, 360 radiator, you could put each of the fans onto these 4-pin connectors over here. I guess nothing else on the top side of the PCB, so the only thing left is the rear I/O of the motherboard. Here, if you look at the rear I/O part of the motherboard, we can find 8 USB 3.0 ports over here, 3 individual LAN ports, so that is quite high number of LAN ports, a clear Cmos button yet again, then a USB 3.1 Type A port and Type C port, and then your 7.1 audio. A big minus is that there's no native Ps2 keyboard port over here. It is not just about overclocking and old operating systems. Many people really use Ps2 keyboards nowadays because you have some features you can get from when using a Ps2 keyboard that you don't get from a USB keyboard, like full N key rollover at like native level. So it's really it's quite sad that they don't have Ps2 keyboard port over here. They could have applied one, because there's definitely some space left over here. So that is one of the big main minuses about this board. But overall, it's the whole thing looks kind of okay, if you ask me. So yeah, so that's pretty much it, how the board looks like. Those are the main features you can see on the motherboard. So I think the next one we can check is the VRM parts of the motherboard. So let's unmount the coolers and so on. So the heatsinks are attached to the motherboard's PCB with small screws from the back side. So by unscrewing them very easy like this, the aluminium shroud comes off easy from the smaller heatsink, and I think it should come off just like that. Oh, so it's I think that is some kind of a networking chip over there. So you can see from the thermal pad, so it's actually not cooling any VRM part on the motherboard. So that is some kind of networking chip. It would explain the three individual LANs on this board. Yeah, there's some text label over there that it's 2x10 GB HT LAN. So yeah, it has to be some kind of a networking chip over there. So yeah. So now we can take off the VRM part of the heatsink. I think have to be careful, but it should come off. And that's how it looks like. So it cools the actual MOSFETs themselves, and wait a minute, so it cools the inductors as well, and top part of the capacitors, it seems. Yeah, and of course the C622 chipset, yeah, that's the one labeled over there. So it is different version than on most of the 3647 boards, but I don't know the differences, but that can be found online. So that's how the board looks like with the without the VRM heatsink. So wait a minute, how many paces is that? Alright, so I had a conversation with Buildsoid about the power delivery components of this motherboard. So the actual PWM controller that is on the backside of the motherboard seems to be some kind of an engineering sample model from Intersil. So there's not like exact model number labeled on top of this. So there's just a Nova 1 BN5 sample, but it should be some kind of an engineering sample PWM controller from Intersil. So the actual power stages and phases themselves are from Intersil, even though I thought otherwise when I saw them for the first time, because there was not that metal contact on top of the actual MOSFETs themselves, which is quite common on some Intersil power stages. But so if we take a look at the front side of the board right now, we can see that there are in total 19 power stages in this line over here. the 18 ones starting from here all the way up to here, they are ISL 99380 power stages. They are 80 amps each. So it seems that the actual input or the power delivery system for the CPU is a double 9-phase intercell system. So this should be good for at least up to like 1200 watts. But truth is though that when compared to the like the ones on Asus Dominus Extreme or the Gigabyte Aorus Extreme, this is actually a little bit weaker. But the main reason for that is the size that they want this board to come into the market. So there's absolutely no more room to generate a stronger VRM solution for the CPU. So if they want to maintain the form factor of this motherboard in terms of size, they cannot really make it any better than this. So when this only has 18 phases for the CPU, plus this one phase over here, this is for VCCSA or for VCCIO, it's different than from the rest of the power stages. They would have to they would have to make the board bigger if they wanted to add more. So the Dominus Extreme as well as the top-end model from Gigabyte, they have 32 phases for the actual CPU. So they have quadrupled 8-phase for the CPU. But of course this is still very, very good. The quality per phase is really, really good. So this uses very new components and 80 amps per phase. That is pretty much the strongest of them all. So the capacity per power stage is stronger than on Asus Dominus Extreme or the one on the Gigabyte, for example. But it's good that they added the water block. So if you run, let's say let's say like AVX load, or especially AVX 512 load for hours and hours straight on or continuously, the water block would be very relevant for maintaining the low temperatures on the actual VRM. So it's really good that they added the water block. When you have so much power going through so small area, they do get hot. But of course, for example, if we talk about like short overclocking tests on LN2, for example, the loads are generally so short that you don't have to run water through the water block heatsink system. Of course, you have to keep the heatsink on top of these power stages because they do get hot, but the water block itself can draw the heat away during those short tests, because for example Cinebench will just last a few seconds when you run it even on LN2. And of course the cold from the CPU pot will help to cool the actual MOSFETs as well. But yeah, so that's pretty much the VRM area of the board. This was the other heatsink here was for that third-party networking controller, and I actually checked the difference of the different PCH options. So the Intel C622 and the C621 are almost identical. The C622 is a little bit more expensive when talking about the recommended retail price, and the only difference I could find from the Intel datasheets on their website was that the C622 only has much higher PCI Express uplink. The uplink of the C621 is only X1, and it's X8 on the C622. So you could run into some issues when if you had, let's say, tons of different PCI Express devices connected and used at the same time. The C622, at least theoretically, has a lot more bandwidth for PCI Express devices than the C621. So it is a little bit like improved version, so you could almost say it's like Z390 versus Z370 at the chipset level. Alright, so that's a quick overview and first look of the EVGA SR-3 DARK. This board has been long awaited. Many people have been asking that will this ever go retail, because it has been pushed forward a couple of times already. since, for example, the Computex 2019. Many competitors got their boards out already very early this year, so this is coming quite late to the game, I agree. But better late than never, I would say. So the board definitely looks strong, it looks really unique, there's no RGB lights on it, so if you like the color scheme, if you really want to get the 28 core LGA 3647 system, you could consider the Dark. Price wise, this should cost less than, for example, the Asus Dominus Extreme. Dominus Extreme is like 1600 euros or 1800 euros here. The so far from the quick information I got, the SR-3 Dark should be costing only like a bit over 1000 euros. Still very, very expensive in the eyes of a normal user, but it should be significantly cheaper than the Asus Dominus Extreme, for example. And there have been some serious issues with the newer batch of Dominus Extreme boards, which have been reported online. So I will test how the SR-3 Dark performs. If it seems stable, then obviously that could be a good consideration for you if you are going to get this platform. Obviously, many would ask now that what is the purpose of the 28 core Xeon when we have the new Threadripper CPUs out there on the market, like the 3950X and the 3970X. They have much better value for money and they have better performance in many workstation situations. But when it comes to pure, like when it comes to real AVX load situation, there Intel still hammers. It is a better performing system than even the new AMD's offerings. Especially if we are talking about AVX 512 situation. There, the 28 core Xeon is still better performing than even the newest 32 core Threadripper from AMD. I agree that Intel really has to step up their game now. The price of the 28 core is way too high, so with a price tag of like 3000 euros or 3200 euros here in Finland, it is too high when you can get the 32 core Threadripper from AMD for 2000. If they lowered the price of the 28 core to like 1600 euros or 1800 euros, it will make it much better option already. And especially if AMD is going to bring the 64 core Threadripper to the market, it will make the 28 core Xeon look bad yet again. But just saying. But even so, Intel options still have their place in the market. They have better performance in AVX situations, and even for 3D, in many 3D situations, Intel CPUs are still often faster. The best gaming CPUs still are always Intel CPUs, but most of the time they are the mainstream CPUs because they have better performance per core. But when looking, for example, the 3D tests like 3D Mark benchmarks, in pretty much all of those, there's always still an Intel CPU at the top. So the 28 core Xeon will be better in many 3D situations with good graphics cards than an AMD Threadripper CPU. But just saying, it's always up to you what you wish to get, because everyone chooses what they want to do with their own money, obviously. But just saying. So, but yeah, so that's pretty much it. If you have any questions or comments about the CPU, motherboard and the platform overall, please drop them down below. If you like to finally see this motherboard in a close look like this, then please give a thumbs up and maybe share this video. But other than that, please subscribe to my channel. And thanks for watching, and I'll see you on the next one.